Alright, we're back. Part 2 continued. Let's not waste any time. Let's get back into it. I was able to get some of the pieces made. I found a resistor that we can use, at least for testing. So, yeah, we left off, and we have to do this trace on the top there. We still have another trace on the bottom to do, a couple more through holes, but I made a new template. For my printer, it was 106% is what it turned out to be to make the template. So I prepared the new trace. Let's get zoomed in here. Oh, wrong way. Going crazy with the buttons. There we go. Let's get zoomed in here a little bit. So we have to make a trace that goes from here to here, and there's a through hole that goes in it. So here's the little trace. I cut it out of the copper foil. I scraped up the bottom a little bit. It's hard to you won't be able to see it, but I scratched the bottom of it with my scratch pen to give it a little texture. And we're gonna put that trace in its spot. So what I'm gonna do is I'm going to throw some solder on this guy. Throw a little bit of thin flux on there. And I'm going to try and get this lined up as best I can. It's not going to be perfect because it's just impossible to do. But try and get it lined up to where it, looks like it used to be there. Actually, that's pretty good right there. Get it lined up. If you can hold it in two places, great. If you can't, of course, my iron's not turned on. But keep it in place. You can shuffle it around a little bit, use an X-Acto knife if you have to give it a little bit of a push or a tweak. But once we get it tacked in place, we can move it around a little bit. Alright, so that's it. Just a little bit of heat, and that's going to lock it in place. So I'm going to push down on the joint here. Make sure I got a nice solid solder joint. Now the edge isn't perfect. Like I have the little miter in the corner here, but I don't have the outside corner. So I'm just gonna take my X-Acto knife and just chop that corner off. And all that's gonna do is just make it, look like it was supposed to be there. So the rest of it looks pretty good. It is overlapping my through hole a little bit on this side, but that should be okay. So I'm going to throw some flux on there. And then we'll do the same thing. We'll solder this side. Now if you can, you'd want to try to avoid getting it into the hole of the via. We can always suck that out, afterwards if we have to. That's not, the end of the world. But we want it nice and flat and in place. And this, I'm going to bridge this whole area with solder anyways after we're done. But that'll hold it in place for now. Now we got to worry about the through hole. So what I'm going to do is I'm going to go from the back side, and I'm just going to kind of hold it in place and just try to work a little dimple in there. You don't want to push crazy hard because you'll rip the trace right back off the board. But I have a little dimple there. I can see where it is, so now I'm going to work it from the top. And I'm going to use my little awl here. I'm not going to use the drill bit because it's really close to the edge of the trace. So I want to kind of force the hole in there, and what that's going to do is it's going to push a little bit of the material into the hole that we drilled. That's okay. We're forming a hole. That's going to help reinforce it mechanically a little bit. And then we can take one of our through holes. It might not go in there easily. Might have to force it in there, but we'll get our through hole in there and see if we can work it down into that hole. It might take a little messing around, but it should go in there, and you want it to be snug. And it is going down in there, so you can use the larger piece to push it down in there. Now we know we have a solid mechanical connection. So we can go ahead and peen that guy over. Make sure the other components are out of the way for our little stand here. Get it lined up. Make sure it's all the way through the board. And then work this over on the other side. I'm not going to overwork this one. I'm just going to, make sure it has the little bit of cone on it. And that's enough. So that'll hold this trace in place, and that will hold this part of the trace in place. Straighten out our resistors. That's really the only way to do that. I mean, there really is no other easy way. We want to make sure we have a solid connection between these 2 points. It's okay if there's a little bit of a hump there, because the piece that sits on top will kind of protect that. But you want a good solder joint. We can wash some solder around the through hole here. Again, we're gonna, might as well just tin the whole thing. We're gonna solder over this whole trace. And these are not, glued in place yet. It's just being held in place by the one through hole. But we have a solid mechanical connection. Once we put the through hole parts in there, it'll be even better of a connection. And that should do it for, all of the hard trace work. We still have some small trace work to go. But progress. We're making progress nonetheless. So I still need to put my captain tape in there to insulate that gap. That's the one thing I did not look for. And it could be, you could use transformer tape. You can use any kind of tape you want, just as long as it's got a good dielectric rating to it. I prefer captain just because it's a little stronger than, transformer tape. It holds up to temperature a little better. I'm going to have to go look for it because I have no clue where it is. I haven't used it in a while. The other thing you could do is you could put solder mask over it. I have that UV curing solder mask. I really don't like it. Either the UV light that I have is no good, or it just does not cure. It stays kind of goopy on me. And I just don't like it. So I am going to use captain tape. And excuse me for a second while I dig through all my junk trying to locate it. It might be on my other workbench. So we have one more through hole to go, and that is for the 1K resistor, and that is cooked on both sides. I do not have a brand new resistor. I looked, I thought I had some, I don't. I have this guy here, which was pulled out of my parts bin, and we're going to have to use that for now. We'll be able to still get a good joint on it, but what I'm going to do is I'm going to solder the one leg. It's supposed to be stood up, and I'd like to solder it in there and then fold the leg over to get a really good mechanical connection. So let's punch a, actually I'm going to get a trace. We have another trace to repair here. I don't know if I have this repair kit It's a very old repair kit that has not been used much. You can still buy these. They're kind of expensive. I think they call them circuit frames, if I remember correctly. I don't know. Since I've started and had this, you know, I still have most of it left. And when I first started out, I wasn't as careful as I am now about, you know, maintaining things, so they got a little bit abused. But I just find a part that's kind of close to what I need, and then I make it work. So I need a through hole to go through that. So there's a couple different ways you can do it. You can drill it, which is really hard to do because this is just like nickel foil. You can try to peen it through and pop it through the hole. That may or may not work. So you kind of got to do a little bit of trial and error and see what works. I'm going to work with it on this piece of wood because the wood will kind of help form it a little bit. You can see I used that, and yeah, that did kind of put a dimple in there, so let's keep going with that, see where we get. I don't know if it'll be enough of a dimple to fit the through hole through there, but we can kind of keep working it until it is. I might get lucky on this one. But I want to get a good connection to the through hole. We can always smash that all down in there once we start putting it together. But I definitely want the through hole to go through the trace. Use the tweezers, maybe ream it out a little bit. You know, anything you can to just kind of help you out. These things are extremely delicate, so I would try to avoid using the drill bit if you can. The drill bit's just going to be a little bit too aggressive, and it'll probably tear it. These things are not very thick, so it went through. I know that's hard to see. We have a trace, and we have a new through hole. So I'm going to drill out this hole. And you can see the board is still brown and black down in there. There's not a whole lot I can do about the inside of the board. You could relay out the whole board, but I'm not doing that. All right. So we're going to put the flat side on the top. I'm about to take these tweezers in the garage and hit them with a torch and melt them. They're on my bad side today. These are my favorite tweezers too. Alright, flat side on the top. Get our little stand here. I haven't figured out yet why they don't make these stands taller, or the little pedestals that go in those stands. Seems like it's like a no-brainer, but alright, we're going to put our trace on top of the hole. And actually, we're going to put it on there upside down. And I'll tell you why in a second. So we're going to line up our trace with our repaired through hole. Use the tweezers to kind of flatten it out around there. And the reason we're going to do it like that is when I flare it out, I want it to grab that and lock it in place. So I'm lining the trace up with the old trace where it used to be. Now, this one's a little bit thicker, that won't matter. And now I'm going to do the flare. That is locked in place. If you didn't solder that, it would still be a decent connection. So that's one kind of way you can cheat a little bit and repair a pad for a through-hole part that's torn off. Let me zoom in. See if you guys can see that a little better. So we needed to make the connection around this through hole and continue along this line that comes over to ground here. And you know, I could have just moved the resistor to the bottom of the board and just connected it from here to here. There's a lot of different things you can do, but this is a restoration type way of doing this repair. You don't have to do it, you know, any specific way. You do whatever you want on your piece of equipment. I'm just trying to make it as close to the original as possible. So it's flared up just a little bit. That's okay, because what I want to do is I want to wash some solder under there. And then I'll over solder it on the top. Now when it comes time to put the part in, I'll make sure that I flux that good and kind of wash it in. And we have that little cone on the end here, so we're going to get, you know, a nice big solder fillet in there. That'll help hold it in place, help maintain the conductivity. So I think we're all right. We can put our resistor in there now, at least one side of it. I am going to space it off the board just a little bit because I do want to get some epoxy in there. And if the repair is successful, I'll order the right resistor. But for right now, I just want to see if we can get the thing working first before we go crazy ordering all kinds of extra parts. So we'll twist that, get it lined up. A little bit more. It's got to come back. Just get it standing up nice and straight. It is getting hot and starting to burn my fingers. Still has to twist a little bit more. Alright, that's kind of lined up. So what I will do to patch in that other leg, since I didn't have the exact part, is I'll just take a lead from some other component, probably another resistor, high current resistor that I have, because I have a bunch of extras. Nice big juicy lead, and we'll just connect that in and put a little solder joint up on the top. Except I would prefer to use one of my cheaper resistors. It's not an ideal way to do it, but it's a way to do it. Since we're kind of limited on what we have to work with, and I don't even really know if this is going to work, we're just going to kind of see what happens. Still nothing wrong with doing, you know, the repair this way. It's not going to go anywhere. Be soldered together. A lot of equipment used point-to-point connections for years anyways. So this should be just fine. The problem is going to be actually getting it soldered in place. Get a decent solder ball on there. Tweezers with a point aren't very good for rotating components. Almost need to grab it from the Let me get a different pair of tweezers. Round nose. So all we're doing is we're just making the leg of this resistor a little bit longer. Tack it in place on the top. We'll solder it in on the bottom. That's actually going to end up being perfect. Lucked out on that one. We'll just make sure we got a nice solid clean joint up here on the top. It works for me. Got a nice fillet on the top there. The through hole is got a nice connection, so now we can go through and finish this joint. So I'm going to just fill this whole area with solder. I want this trace to lay flat, so I'm going to hold it while I drag the iron over. And you can do like a little TIG welding on these traces too. Just make sure you get them connected good. And we can check for continuity, but I know that that's a solid repair. So we'll go from ground to that leg of the resistor, and then we'll check the other side to this, and we have a good connection. So that is done. Move him out of the way. Now we gotta do... Let's do our coils next. Let me go get that Captain tape. Try and find it. Give me a second. Be right back. Captain tape is MIA right now, so we will use transformer tape. It'll be just fine. We're going to coat this whole area with epoxy and silicone, and it'll be fine. all we're trying to do here is just keep the two legs of the bottom of the coil from shorting out to the one trace that's below. So we only need it on the one side, on the one component. So I'll double it, make it double thick. Just drop it down underneath there, and we should be fine. And you could probably just put it on there as is. I don't think it would really hurt anything. But this tape, you know, it works good in insulating transformer layers, so I'm sure it'll work good insulating the two legs of an inductor. Cut it to size. You don't really have to be as crazy as I am about cutting it. But all we're trying to do is just protect one trace. That's it. Okay, I'm going to clean the board before I stick this down. Just to make sure there's no flex residue hiding underneath it. I am going to cut it a little bit thinner. A little bit thinner yet. Want to make sure it's not resting on the pads. A little more. One layer probably would have been more than enough, but OCD kicks in sometimes. And all that's doing is just keeping the magnetic part of this from touching anything it shouldn't. And what we can also do is just space it up off the board a little bit so it's not touching the traces. Now, I don't know if these were installed in a specific direction or not. Actually, I need to go, I have another amp. I'm going to go verify that. I don't think so, but let me go check just in case. I really don't think it matters, but we're going to put them in this way. Get it in there good and tight. I'm going to get this down into the groove in here so it sits where it's supposed to sit. It's about as flat to the board as I'm going to get it. Let's solder it in. A little more heat in there, help out. Much better. I want to make sure that this via is full. So we'll solder that flat. And it top soldered itself too, so we're good. Nice joint. The other side, there's not a whole lot I can do. We have surface mount components in the way. Alright, not bad. That'll do it. We have one in. It's not sticking through the hole as far as I'd like it to, but we have a good connection on both sides because there's a through hole there. I think part of the reason from that is the one leg is not going all the way through, but we should be okay. We have multiple points where the connections are made through the board on both sides, so I think we'll be alright. Not too worried about it. And we have 3 different connections made on both sides. Should be fine. Next, we're gonna try the large. Let's do the small. No, let's do the large resistor, large capacitors next. So remember, we're gonna stand these up. I'm going to space, I didn't want to, but I'm going to end up spacing this off the board. That transistor is in the way, and it's not going to play nice with what I want to do. I really should have drilled that through hole in a little bit farther. I don't want it touching that, so I'll space it up a little bit. It'd be a lot easier if the board wasn't damaged, but we'll work with what we got. So we have one there and another one here. And these are replacing the L-tone capacitors. The other thing is the inductors don't sit quite in line with one another. They're offset. Maybe they do sit in line. It doesn't look like they did. Yeah, they sit alright. Let's get this guy soldered in. Again, at this point, we're still kind of experimenting because I don't know if this configuration is going to work or not. This is new to me. I haven't done a repair like this. This is generally outside of the world of repair. Make sure we get a good solder flow on that. We can go ahead and cover this one now. And I'm not putting too much on there. I'm just putting enough to cover that whole trace. Just to make sure that it's connected. Increase the current carrying of it a little bit. And making sure we have a good connection. The whole bottom side of this is going to have to get epoxied to hold everything in place. I really don't know any other way to do that, because the traces are kind of floating. It's not anywhere near as good as you know, the board the way it was originally made. It's good enough to work, but it's not going to be like manufacturer new. Let's see if we put these caps on the inside. They might fit, probably not. The problem with using axial caps versus radial is they don't have offset leads. Since they were designed differently. You gotta improvise a little bit. This guy is not gonna go down in there nicely. I don't want to jam them down in there. I want them to be somewhat loose. And we're going to use our leads for connections. So I'm going to tack the outer leads in place, leave the ground ones kind of free for now. Just kind of set them so they're at the same height. And hope for the best. These are going to have to get top soldered. I can see that already. Might as well. I want these to have just as good of a joint as the other ones did. Hit the tops of them, hit the bottoms, and then we'll suck it out from the bottom. you have a lot of thermal mass there, you might have to sit there and cook it a little while. Eventually it'll come clean. Alright, that should flow onto the top now when we hit it with some heat. I gotta zoom out a little bit there. Always forget to do that. Alright, it's a little better. Alright, so we have large caps that need to go in here. There's a big board that goes across here. So actually this guy has to be straight. So we gotta find a way to get the large caps and the radial film caps to play nice with one another. And I think the only way to do that is going to be to stand them up. I can't really put these on the bottom. They sit kind of nice like this, but that doesn't give me access to those bottom leads that I need. And it puts it really close to that resistor. That ain't gonna fly. And the other thing I can do is I can kind of tease the leads a little bit and give them an offset. I generally don't like to do that, but sometimes you have to. Let's see how that. Yeah, they do play a little nicer with a lead offset on them. So I think that is the solution. Just gotta fold them over and do a half a plier jaw offset on the leads. First one came out a little better than the second one. Well, I think that's how it's going to play out. Get rid of this block of wood here. They seem to fit in there kind of nice. We can blob some silicone in there to make them play nice. It's not ideal, but it's better than nothing. Said I don't know any other way to make these work. You can't get those caps anymore. I mean, you might be able to find new old stock, but those things sucked anyways. I wouldn't want to put them back in the amp. That's why all these amps were dying. So, let's see what happens. Let's solder this guy in there. Let's get his buddy in there. Roughly at the same height. And then we can tweak them and adjust them as we need to. Let me clip these leads. It's going to be too hard to solder them standing up. Right, they all need more solder. More solder and more heat. They are now soldered through on the top. This one outside one needs a little bit more love. Looks good. Better than it was. Alright, so now we have the two replacements in for the small LE tone caps. The two leads on the inside are our grounds. We're not risking shorting anything. The resistor can happily sit on the side and get hot. And now we have the larger two. We have this guy here. And these leads are just not long enough when you fold them over. So I think we're going to have to do this. We'll go from here and cross over. I think that is our best course of action. Fold it over nice and close to the top like this guy. I don't know really what else we could do here. I don't have the yeah, this is how it's going to have to be. And what I'll do is I'll just bend these over and connect them in. That is my best option. If anybody that's watching has another idea of how to do this better, please let me know. For now, this is what we're doing. We're going to solder them in with the leads facing straight. Again, I preloaded that side with solder because I want to make sure that it melts on both sides. I'm going to hold it upside down. So I can hit it with some heat. And just for, well, I know those are connected because they're connected with different through holes. They're connected in a few different spots, so we don't have to worry about that. So now we just have to bend our lead and solder it to this guy. And that is essentially where we'll get our ground from. It's not pretty, but it should be effective. I'm going to run both of them on there. So we'll do one on one side and one on the other side. Get a nice good joint. Sometimes you have to cheat a little bit, you know, like you're stuck with an awkward situation where you can't really get things to play nice together. You gotta do what you can do. I'm just lightly tacking this guy in place. I'll hit it with the hotter iron after I get it positioned where I want it. I wonder if it would be better if I hook those. It would be better if I hooked them around and underneath that. Like a legit point-to-point connection. Let's see if I get enough lead to get them underneath there. Yeah, I should. Let's try it. Let's try it out. I have spares, so if I break it, I can put another one on there. Well, it doesn't sit as pretty as it did, but that connection won't go nowhere. Let's see if I can make this one better. I don't know if I'll be able to squeak it through there. If I can, I'll change the other one too, make it look pretty. I do like that better. Nothing says we can't redo the first one, right? I know this is probably boring as heck to watch, but I want to make sure I'm doing a good job here. So we're doing a point-to-point to get our ground connection for these rear capacitors. And the reason that we're doing that is because I have no good way of getting these into the ground. Ooh, I'm glad I did take that out. I forgot to repair that one trace on the bottom. I'm glad I did. In the second part of that part one, we had that little trace that had a breakdown in here. We need to repair that before going any further. I have a circuit frame already cut out that I can use. So yeah, we gotta fix that. Fix that line right there. That would have been bad to forget that. We're working through and almost forgot that. Save that little piece for a rainy day, which will probably be tomorrow because it's been raining like crazy here. And let's make a trace. I'm at the point now where if this thing works, I will be extremely lucky. We're beyond skill here. We're at luck. Alright. That trace repair is done. I'm just going to try and make it nice and flat. Good enough. Get in there with a cotton swab while we can, clean it out a little bit. Check for continuity. See, there's probably a 20% chance the first time this thing turns on, it goes up in flames. Might be interesting to watch. I hope not, but you know, sometimes that happens. Alright, trace is fixed. Let's put our cap back in. Actually, we're going to bend it first. I'll know next time to leave a taller loop on those if I have to go back into grounding them that way. Can't get everything right the first time. Use my little stick to put a nice loop in it. Alright, caps are in. I'm gonna have to cut this one a little bit. Alright, let's solder them in and check our connection to ground. That's about the only way I can think to repair that. So ground is our big plane there. It connects to this resistor. And we're going to flow some solder over that because I want a nice clean connection there. Looking good. Alright, let's check our ground. Do we have ground on our capacitors? It's on the other side. Where is ground? Ground is... Give me a trace that goes to ground. That doesn't. That doesn't. The bottom of that does. That's isolated. The one that's... Alright, so the bottom leg of this resistor here. So what we're doing is we have the ground plane here. It's coming up through the two center legs for these capacitors. And then we're bridging it over to the other two legs on these guys because the original through holes would have been covered by the caps. So the original caps were about the same diameter, but they had two connections below them. The wires on these were not long enough to get down there. So we did, you know, all we could do to get those connected in. We almost have a functional board at this point. Or what should be a functional board. We don't know if it is capable of functioning. I do have the control board that goes on there. Here is the gnarly large set of coils that goes on there. Some of the silicone is just not going to come off. The only place you really want to get it off is on this side because that's where it goes up against that board to hold that board in place. So again, you know, don't use tools, use your fingernail. Just kind of scrape it off best you can. Doesn't have to be perfectly clean. The new stuff will still stick. New silicone does stick to old silicone, maybe not as well, but it still sticks. And the gnarly old glue that they used on the bottom of this, we are going to glue this back on, but I'm going to use E6000. E6000 is a much better glue and it will not become conductive. So I'm going to just hit the bottom of this with my little X-Acto knife just to get, you know, any residue of old glue off. Just because that glue might be conductive, you know, over time the glue does break down and become conductive. That is one of the problems with this guy. So it doesn't have to be perfectly clean, just clean enough. Clean enough to where you know it's not going to short anything out. Alright, we already checked our traces. We know the one little trace there is good. We did our patch on the small trace that's in between the caps. Our makeshift resistor is in there for the time being. We can always change that out later. Yeah, all that is left, or all that I think that is left on this part of the board, is to get that guy in there. So we're going to put the inductors in there, and then we can finish recapping. I got to dig through my box to find the caps that I ordered for these. And it'll be break time until tonight after that. So I'm going to glue this first and then we'll solder it in. You don't need a lot of glue, just a little blob on the bottom is enough. Just enough to spread it down in there and hold the board down. E6000 is great glue. I've used it for numerous different things, and it seems to survive and last. We checked these traces over here. We know those are good. Just verifying nothing else is in the way, because once this is glued, it's not going to play nice with coming back off. And I'm going to try and push it towards the back of the unit. Like, I want the glue to try to go this way. I don't want it to go towards the leads. Solder time. So we're going to tack all the leads in. Then I'm going to flip it over and hit them real good. So we got them mounted and glued. Now one at a time, we're going to give them some heat. Make sure they're bonded on there. I know that doesn't look beautiful, but it's pretty darn good. Pretty darn good. Solder's a little bit wavy. It's not perfectly flat, but you know what? There we go. It's a good angle. So you can see everything's on there and connected. And up here, it looks like a board again. So, it's 3 o'clock right now. I have a family event at 4. So I am going to shut down for now. Hey, the camera's working. There we go. So I'm going to come back later tonight and work on finishing recapping this board, work on recapping the little control board, and hopefully we can put this thing back together and it will be up and running. I got to do a little checking on some of the components on here. Some of these things look a little bit gnarly. I'm hoping nothing is damaged. There's a couple resistors that look a little, you know, like they need some attention. But other than that, hopefully we can put the control board back in and fire this up. It'd be really nice to get some sound out of this thing tonight. I'm sure the owner would be thrilled to have his amp back, and I'd be happy because this was a pretty complicated repair. So I hope you guys are enjoying this so far. We'll have part 2 continued again later tonight, and we'll see if we can make this amp work again, and then we'll get it buttoned up and maybe move on to something else. So thanks for tuning in. Remember to like and subscribe, and I will be back when I can.